We have seen deletion of node in single linked list at head position. Time complexity of deletion at head will be big of 1 time. We no need to search for node to be deleted, so it will take constant amount of time. Now we will see deletion at tail in single linked list. Let's assume we have 3 nodes in our list. Here I am using insert head function to create linked list because it is more efficient than insertion at tail. Its time complexity is big of 1, whereas insertion at tail time complexity is big of n. To delete a node at tail position, first we need to find the last node within our list. To access and delete that node, we need one reference. So we will use one pointer variable to find the last node. Let's call it as temp. After deleting this last node, then we need to perform one more operation. This second last node link should be set as null. So assign this set value to this temp pointer. Actually we require 2 pointers, one to point this last node and another pointer to hold this second last node, because we need to set this second last node link to null after deletion of this last node. Instead of taking 2 pointers, here I am going to use only one pointer and move that pointer up to this second last node. If temp is here, then this last node can be accessed as temp next. If you write while temp next not equal to null, temp will move up to this last node, but we want to make this temp pointer to point this second last node. So we need to advance this temp until temp next not equal to null. So while temp next not equal to null, advance this temp pointer in forward direction. See here, temp next means this 1040 here, temp next means this 1024, which is not null. So we need to advance this temp. After increment, this temp is now pointing to this second node. Here temp next is 1024 and temp next is null. So this condition will be failed. So temp will not be incremented. We need to delete this last node. How can we access this last node? Temp is here. So temp next will be this one. Now we can delete this temp next by using this free function, and we need to set this last node link to null. We can do that by placing null in temp next. Suppose we want to perform one more deletion at tail operation. Repeat the same process. Initialize temp with head, but see here temp next is null. This is null. So this temp will not be incremented. Temp will remain at this node. Then we need to delete this last node. So here last node is deleted. Again we need to set this last node link to null. Here null is placed within the temp next field. If we want to delete one more element, again temp will be initialized with head, but see here temp next is null. This entire part is null. Null means not a valid address. We are trying to access invalid memory. So we will get segmentation fault. So when only one node is present within our linked list, we should not use this condition. So to handle that special case, add this if block. If temp next is null, here temp next is null. So delete that node. Now list is empty. So we have to set this head to null. Now head is set with null. If head is null means linked list is empty. So we cannot perform one more delete operation. When head is null, raise this error, cannot delete node from empty list. Suppose if we have n nodes within our linked list, we need to find second last node within our list. So it will take big of n time. This is a complete program to delete a node from single linked list at tail position. Here I am using our previous program, create single linked list using insert node at head. Here I am adding this delete tail function to the same program. This create node function will allocate memory and store data within the new node data field. This insert head function will add new node at starting of our list by placing head address in new node next field, and this new node will be made as head because new node is inserted at starting position. Here I am going to explain this delete tail function in detail. You can see more detailed explanation for create node and insert head functions in the video creating single linked list by inserting node at head, link provided in the description of this video. Here we are using temp pointer. It is assigned with head value. Suppose if head is null, means linked list is empty, we cannot perform deletion. So we have to return to the calling function. If only one node present in list, in that case temp next will be null. Then delete that only node. After deleting that node, list will be empty. So set the head value to null. Again control will be returned to the calling function. Suppose if we have more than one node, find the second last node within the list, then delete the last node. After this while loop completion, temp will be at second last node. So last node can be accessed by using this temp next. So delete that last node, and after deletion set the second last node link field to null. With this statement, this display function will print the linked list. If we execute this program, here we are calling insert head function 3 times. So after adding 3 elements, this is our list. Here we are adding element at head position. So first one is added to list, 2 is added before 1 and 3 is added before this 2 and 1. After adding 3 elements, then we are calling this delete tail function. It will delete the last element in the list. Here this is the last element. It will be deleted from the list. So our final list is this one.